Hello, this is Ty Piazza, Refining Industry Sales with VEGA Americas. Today we're here at RefComm Global 2020 in their virtual exhibition. The title of today's presentation is Improving Coke Drum Level Control. The goal of the presentation is to understand the advantages of VEGA's Coke Drum level system so that you will feel confident upgrading your current level instruments to the ProTrack configuration. As a means to achieve this goal, we're going to discuss who VEGA is, and then spend a little bit of time around the Coke Drum level system itself, background, current situation, various configurations, and then discuss some gamma switch alternatives, alternatives to neutron backscatter, that is, and then focus on some takeaways. And in this case, we won't have live questions, but we do appreciate your opportunity to provide those questions to us during the Q&A of our virtual exhibition in November. So who is VEGA? The name OMART or OMART VEGA, those are all previous names of the company that falls under the VEGA Americas company today. And so I think a lot of the installations that we might have in the field still are known as OMART VEGA. But again, it's the same company and just branded differently today. The company, though, still does level pressure and density instrumentation. So as you can see, we have level technologies for liquids and solids from a point level perspective. We have continuous level with capacitance, pressure, radar, guided wave radar, ultrasonic, magnetic level indicators, as well as gamma continuous level. And what we're going to focus on specifically is the gamma part of our product offering in today's presentation. VEGA is a global company. We have mirrored manufacturing facilities, one in the south of Germany, the other one in Cincinnati, Ohio in the US. And based on the global need, we sort of share the manufacturing capabilities based on the current demand. Logistically speaking, we support the Americas out of the US, and then strategic locations around the globe. And then out of the factory in Germany, they support the vast majority of the other locales. So here in Cincinnati, we do have a fully integrated manufacturing facility. We also have a sales and training center. Within our training center, as you can see on the bottom right-hand side, we do have an opportunity for customers to work with the radiometric equipment as well as our non-hazardous materials with the guided wave radars, non-contact radars, and pressure transmitters. So it's a nice opportunity, perhaps in the post-COVID world, to actually work hands-on with some of the instruments that may be more challenging, perhaps in your refining environments, to actually replicate those calibration conditions. So something to keep in mind that's always available for you. And specifically moving forward in more of a virtual environment, these trainings are always available for your access. So one of the things that makes VEGA unique is that 80% of our instruments are available within 5 working days from the factory. Specifically for Coke Drum systems, whether you have a density device or a switch or a continuous level, these devices are available for emergency stock in Cincinnati and can be shipped within 5 working days. So for those of you who are not familiar with radiometric technology, why would we want to use this type of technology on our industrial applications? So here's a couple of bullet points on that. And for those of you that do use radiometric technology, you would have this information at hand, but it's non-contact into the process, so it's unaffected by high temperatures or pressures or aggressive media, such as in a Coke Drum. There are no moving parts, so high reliability of your actual instrumentation. And I think most importantly is that we can commission these instruments without process shutdown. It requires careful calibration. However, because it's non-contact in the process, we can commission these devices at any point in time. So Our experience on coke drum level systems goes back quite a long way. Certainly in the early 1990s, we did have a level system that we provided for a fair number of customers. We did find, though, that the system was heavy, it was a little bit bulky, and it wasn't something that was as ubiquitous as it is perhaps today, based on new instrumentation opportunities in the advancement of the technology. We do have quite a bit of technology experience, even prior to some of the neutron backscatter technologies. And some of the things that we um, try to acknowledge in the refining space is that, we are refining heavier and heavier hydrocarbons that do produce more resids. So the forming characteristics are ever changing, and we want to really prevent any downstream catalyst following, which can really prohibit the efficiency of our process. And so what we'd like to do is we like to address the idea of improving throughput by increasing cycle times and reducing the total number of cycles per year. From an operations perspective, using less anti-foam, all that has to come out in the process at some point, and so we can reduce that on the front end. We love to do that. And then managing foam over. So if we do have constraints from a capacity perspective, we want to measure it. We want to run as high as we can in those drums. Providing good level indication allows us to do that in a very efficient and most importantly, a safely manner. So some of the existing technologies that you might see on coke drums would be our neutron backscatter technology. So I think most of our end users are very familiar with this type of technology. But at the end of the day, it's a non-contacting neutron emitter, which, when calibrated properly, can provide a number of various outputs for the end users. So when calibrated properly, you should be able to determine the difference between light foam and heavy foam, dry coke, and then water saturated coke. And so these, I think, are some of the important characteristics of a neutron backscatter device, and where they're generally located on the drums allows for some level of process control. And so one thing that we would notice is that these devices don't pass energy across the entire diameter of the drum. It really only measures about 18 inches inside of the drum. And so if you do have very dynamic foaming characteristics or coking conditions, you may or you may not see the leading edge of the level with the neutron backscatters. But when put in place, generally we see that these devices provide indication when foam arrives, when it is appropriate time to add anti-foam, and then at what point do we actually get to our switch out location. And for any type of foam up that might occur, we do have a high level foam alarm that we generally see with our customers. And so these are a couple of photos that we've seen in the field of some of the older style neutron backscatters, but also some of the newer vintage. And in either case, though, it is our understanding that these technologies are no longer supported with respect to new sales. There is some service and support perhaps available, but the idea is that long term, these technologies will not be supported. And I think that's where we're going to talk a little bit about how gamma continuous level can fill that void. So when it comes to gamma transmission, the way that these systems work is that you have a source, which is cesium-137 normally in our case, and you have a detector. That detector, it reads the radiation field, and then based on the amount of radiation it receives, can produce a signal for us. And so on a low level condition, we're getting a lot of radiation to our device. And in a high level condition, we're not getting a lot of radiation to our device. And so what we say is that since this isn't a contacting measurement, this requires careful live process calibration for the most accurate measurement. And so it's an inversely proportional level measurement, but it's extremely accurate. And it's accurate, and it creates a lot of reliability improvements from more mainstream, more common level technologies like differential pressure, radar, etc. Specifically for those very heavy services. When it comes to the actual Detector Technology. We have a very modern, compact design, all designed to the newest engineering standards. We also have very convenient tools for configuration, as well as for setup. We believe that this sort of state-of-the-art package does allow for a faster delivery, a more reliable, more stable signal long term. And then the fact that it's lighter and smaller and compact allows us to provide these instruments for you much quicker, specifically in a repair type of a scenario. So when it comes to your continuous level devices, we have devices for specifically for our coke drum measurements. These are single level devices that are available in lengths up to 7 meters. So we have our standard FiberTrack 31 offering, and we also have a more sensitive version of the same construction that might work better for applications where you have existing sources that you're just trying to upgrade instrumentation to, or perhaps it's a new project and you're looking to reduce the source activities where possible. And then we also have our highly sensitive rigid bar scintillators that are very sensitive, but available in lengths to 3 meters. So again, a great option for perhaps new projects or where you have access to new decking and new platforming. So as a complement to the level system, we do have density devices and point level devices that help provide inputs to a very accurate continuous level system. And so if we look at the various points of concern or consideration within a coke drum cycle, our level system is basically going to be a very accurate gas gauge for where you are inside of your drum at all times. And so what we can see here is if we walk through this this chart of a single coke drum cycle, you can see where we're obviously back warming, and now we start to fill into the drum. We're going to continue to fill until we get to the point where we're going to add the antifoam. The antifoam is going to drop our continuous level, and we're going to continue to build that until we get to our switch out point. Once we reach that switch out point, the drum is going to be depressurized, and we're going to sort of see that foam bed collapse and slump, so to speak. And then once we quench it, we'll be able to identify as we get to our max water fill location. We'll drain that water. That'll give us a good indication of where we take our outage. We'll drill it and then release the coke, and then we'll start to back warm and repeat the cycle again. Some of the configurations that we might consider for a coke drum depends mainly on the needs of the customer and perhaps what accommodations have been made by the licensor with respect to the design. So we have a couple of different tiers of our level system based on, again, those needs by the customer or the licensor. And so we have a very straightforward continuous level device, so a single span. And then we also have our vapor density gauge. The vapor density gauge does help to provide a very accurate and compensated measurement to our level system, especially if you get closer towards the end of the cycle where your vapor density does increase, the attenuation of the radiation does increase, and therefore you want to protect against any false level indications. And additionally, what this device can do is it can provide a very reliable indication of when you're getting towards the end of the cycle and you're bringing particulate over into the overhead lines. So a very important feature within our level system. And then we also have the auto zero device. If the drum is not between cycles polished properly, or there's bits of coke left in there, what this device does is it makes sure that our level system always reads zero when we start a new cycle. And so if you do have buildups and things like that on the wall, if without this system, you might start to read 1, 2, 3, 5% of level, even though you're just back warming. And so this device here makes sure that we're constantly reading a zero until we actually are coking up into the level system. For customers that are interested in more level span, we certainly do have the opportunity to provide multiple level devices covering a larger span. So in this configuration, we're covering probably the top third of the coke drum. And this provides a lot of good indication for when we're actually coking up into the system. We can see initially where the antifoam usage comes in, and then we get to be able to read a nice clean outage measurement at the end of the cycle. And so again, we're just combining additional level system with our vapor density and our auto zero devices. So when it comes to a comprehensive level system, we have all of what we had in the other level system with respect to the 2 continuous level, the vapor density, auto zero. We also are including a target switch. And this target switch is generally located at perhaps a location of one of the old existing neutron backscatters, but more importantly, it's where the refinery or the process licensor says that this is going to be our target point for when we want to get out of the drum. You can also include this where you want to start your antifoam injection. But again, a very reliable means to have a local level indication. And so if we look at these this set of coke drum trends here, you can see on the bottom axis your auto zero, your bottom level, top level, your overall level, as well as your target switches. And so we know based on the auto zero gauge when we come into the drum, we know when our top level takes over from our bottom level, where our 50% of our measurement span is. And then additionally at our 65 and our 75% point, this is where our gamma continuous level comes in at the same point where our gamma switches come in. So this is an area where we can very easily make sure that our systems are calibrated properly, and it also gives a very clear indication for operators where they are at any point within the coke drum cycle. So something to consider as well is if you do have existing neutron backscatters or you have an existing continuous level system and you want to add some target switches. Adding gamma target switches is quite straightforward. If you have an existing level system, gamma level system, all you can do in that case is, all you need to do, I should say, is add the point level switch wherever in the measurement span that you'd like to put it. If you don't have a gamma continuous level already, what we can do is we can provide you 1 or 2 sources that actually cover the entire span of the vessel, of the measurement span, and then at that point you can locate your point switches wherever they need to be within that span. So with respect to some of the functionality of these target switches, we believe that this replaces 75% of the functionality of neutron backscatters, and it's as easy for the operators to understand. We're not going to be able to provide the density outputs, the difference between the foam, the coke, the water, etc. But what this device does is it's always going to provide you the leading edge. And so we believe that the functionality that you're going to get out of these switches meets much of the demand that the current neutron backscatters are being used for. So we would hope that if you're adding this to an existing level system, you're not having to add new sources, you're not having to add redundant platforming. So the continuous level, I think, as an added benefit, will track with the gamma switches. I think this is really important to have multiple redundant measurements within your level system. We find that the gamma switches can be calibrated within 15 or 20 seconds. So it's an extremely straightforward and easy calibration procedure, and some might say easier than calibrating the neutron backscatters. And again, switches will help to improve the calibration of the continuous level. Many times customers try to match up the continuous level with the neutron backscatters. That's a process that's never going to work. They're 2 totally different measurements based on different measurement principles. And so to say that we now have the ability to essentially calibrate our continuous level to our known elevation points by our gamma target switches is hugely valuable. And again, we find that they're very easy to mount. They're extremely lightweight. They can be mounted to maybe just some unistrut, or better yet, the conduit from your existing continuous level system. So with respect to what I want to make sure that you all take away from this short presentation here is that VEGA has extensive coke drum level experience. So we have more than 325 or so installations around the world. And so through this extensive experience, we hope that you will find that we've introduced the most modern and robust level technology for the coking application. So we've also designed this in such a way that it creates the best functionality for your specific coke drum process. We know that not all delayed coke drums are created equally, and there are some nuances to that. And we feel like our experience has given us that functionality today, and we really be interested to see if this is something that would fit your process. And so I think in closing, we'd ask that during some of the breaks and some of the Q&A sessions, you definitely provide us your questions and your concerns, perhaps to our virtual booth, and we'd be happy to help address those. And certainly, we look forward to seeing all of our end users, all of our customers in person, perhaps next year at RefComm in Galveston. But I want to thank you all for paying attention today. And really, we hope to see you at the virtual booth in the very near future.